Great, yeah. So thanks everyone for being here. Again, this is super casual. Hopefully should be fun and informative. So this is the collab event between Bloom and Web3 Baddies. So a little bit about Bloom. So Bloom is an organization that Gabby and I started in order to educate people about Web3, specifically folks who identify as women or genderqueer. And really our mission is to bring more gender diversity into the Web3 ecosystem. We'll give intros about ourselves in a sec, so you can get to know us a little bit more. But the reason we're doing this with the Baddies is because we are mission aligned. So I joined the Baddies by invitation from someone actually who went through Bloom in our first cohort. And it's been an awesome experience. Highly recommend Baddies to everyone. I've been talking about it probably nonstop, so like everyone I know for the past month or so. And so the Web3 Baddies, for those who don't know, is a organization, kind of like a social DAO, trying to figure out its identity still, but like mostly a collection of people who are women of color, queer people, and just generally like people who share similar values. You know, because we are mission aligned, it felt like it'd be a good opportunity to do this little collab. And that is why we are here now. So I will start by going into some intros of who we are. So myself and Gabrielle. So Gabrielle, how about you go first?
Yeah, hi everyone. Super excited to be here and talk about some fundamentals with you all. My name is Gabrielle Hibbert. I use the pronouns she, they. I am one half of the co-founders of Bloom, and I am a security researcher and engineer by day, and I am based in Washington, D.C.
For my intro, I'm Val. My pronouns are she, they as well. And I am also the second half of the Bloom program. So let's see, for my background, I've been in the Web3 space since 2017 alongside Gabrielle. We started in the space around the same time. And we actually only met like pretty recently though, and connected and decided to work on Bloom together. But yeah, basically I had a background in information science. So that's what I kind of studied in my undergrad and my graduate studies as well. And then from there, I went to work for like a large corporation in the US, and then I really hated it. And then I learned about Web3 and like all the cool technology that was happening at the time with Bitcoin, Ethereum, and just really got into the technical aspect of the things that people were building and the possibilities that were available to use those tools for like social justice and empowerment. So that's kind of how I got into the Web3 ecosystem in general. And then right now I'm working for a company called 3Box Labs. So we're a startup in the space. We're working on a protocol called Ceramic Network. And that's basically what I spend most of my time doing. And then outside of that, working on Bloom and collabing with the Baddies.
All right. Super excited to talk about the Cypherpunk movement and a little bit about crypto primitives. So these are kind of, I would say, the bread and butter of the space. And I feel very, very important to understand, not just in conceptualizing how the movement started, but where it might actually go in the future. And I hope this will be interesting even for those who have heard me talk about the movement and primitives before. Maybe you'll learn something new tonight. So already did my intro, but yeah, let's go ahead and get started. So the cypherpunk movement, what is it, when did it get started, and who are those people that are listed below? So the cypherpunk movement really started around the 1970s with Jude Milhone, or she's otherwise known as St. Jude. So she is a Washington, D.C. native, and she worked to really advance not only the programming space, but also to advance civil rights. So there's this amazing mugshot of her where she actually got arrested during one of the civil rights protests. But the reason why I bring her up is because she really helped define this movement. She advocated for privacy and advocated for really looking into how cryptography could help in both political and societal ways. So she's written a ton in the space, and I encourage you all to check out any of her works. But I really want to focus on Eric Hughes and Timothy C. May. These are two of main people in the space who you may hear of as you learn more about the cypherpunk movement and cryptography. So Hughes wrote a cypherpunks manifesto and discussed that privacy is basically the basis of an open society. And he also discusses how an anonymous transaction system is not really predicated on secrecy, but whether individuals can reveal information when and how they want. And this is all really being built by a widely dispersed system, otherwise known as dispersed or distributed systems. And the part that really intrigues a lot of folks who read his work is that he talks about how this distributed system cannot really be shut down. It's very hard to shut down. And this kind of kernel that people unearth is really talking about this notion between centralized movements and decentralized movements. And we'll talk a little bit about that later with Val, but this is just to kind of put this in your head that conversations around centralization versus decentralization and distributed systems have really started with Hughes. And really going off of Hughes, May, who wrote the Crypto Anarchist Manifesto, a lot of manifestos in this space, really discussed how the state will, of course, try to stymie and halt the spread of this technology by citing national security concerns, the use of technology by drug dealers, tax evaders, and really talks about this fear of social disintegration or moral panic with cryptography. And I'm sure most of us have heard this time and time again when crypto is brought up in the news. It's framed as this piece of technology that the morally bankrupt use, which is not necessarily the case. So what May also brings to light is that he believes in the power of cryptography and privacy enhancing tech to create societal and political change, just as Jude Milhone talked about. And I really encourage all of you to look at these pieces. They're very, very short. Both Hughes and May wrote one-pagers on both of these topics. And when you read through them, you'll see that a lot of what is written about the space currently, especially in Satoshi Nakamoto's Bitcoin white paper, really shines through, which I think is a very interesting way to pass along the history. And while there are so many other scientists and activists within the space, I do want to kind of sum it up with this little quote that I kind of thought about while reviewing my notes and looking at a lot of the past writings is, with this movement, you can kind of view it as an oath that a lot of folks in the movement kind of ascribe to, where you're placing your trust in this mathematically verifiable code, you're placing trust in privacy and measured knowledge. So to kind of break this all down, I want people to take away that this movement is not really about putting your trust in third-party organizations who have immense control over our data. We should really be able to control who has power over some of our most personal data. We should be able to protect our privacy and trust the cryptography or mathematically verifiable code. And while I don't have too much time to really go into the later movements of code is law, it's very interesting. Don't necessarily subscribe to all of what that belief system entails, but you'll hear code is law, and this is what a lot of it is based off of. It's based off of this movement that kickstarted in the 1970s. But to kind of tie this even more full circle, because I did do policy before moving into Web3, is that this isn't necessarily new. This conversation has been happening since the late 19th century. Two lawyers by the name of Louis Brandeis and Samuel Warren really talked about this in 1890, with their piece entitled The Right to Privacy. Basically, there are these two hotshot lawyers who talk about these tabloids who take pictures of them while they're going to this starlight wedding, and they don't want their picture taken. So they talk about how the lack of privacy law in the US is honestly shameful. And it's a very, very modern piece. And I really think this conversation around privacy and data honestly starts in 1890 and not 1970. But to kind of bring the movement to the primitives, we'll be talking more about what are these activists and authors really talking about when they're talking about cryptography. So transitioning just a little bit, we're going to be talking a little bit more about the science behind it. And I do want to say that cryptographic primitives and cryptography in general is a huge science within itself. So this is the quick and dirty version of it. And I am happy to answer any questions at the end of all of this. But let's get into it. So secure hashing algorithms, encryption, and key derivation. What is all of that? So before really getting into the primitives, I do want to talk a little bit about encryption, security, and cryptography. How do all of those three things relate to one another? And just to really break it down, encryption is the means of securing digital data using a combination of mathematical techniques. And these techniques can range from hashing algorithms or weak passwords like password 123. And please don't do that. That makes me sad as a security engineer. Don't use weak passwords, please. Cryptography is obviously the study of how to secure data against an attack. And you can kind of think of three main areas of cryptography when you read about it. The first is secret key cryptography. The second is public key cryptography. And the third really encompasses hashing functions. So with that, kind of both combining encryption and cryptography, you get kind of the study of security, or how we can best protect ourselves against unwanted threats, or as we say in the security realm, attack vectors. So one really cool way of protecting against attack vectors is hashing functions, which again, huge field of study, and this is the quick and dirty version of it, but we'll basically be talking a little bit about what all of this means and where you'll find them. So the secure hashing algorithms you see here, you may have seen written about when you see things about Bitcoin or about Ethereum, but what are they exactly? So one, these are the standards that are basically used by most developers in the space. And we get these standards from the National Institute of Information Security right here in DC. And what makes hashing functions super special is that they are one-way functions. So you can kind of think of it as you put an arbitrary amount of data within this hashing function, it digests it, and you get a completely different set of data. And you can't transform that data once it's passed through that function. Super, super cool, super fun. I really enjoy working with them. And when you look at the numbers at the end of the algorithms, those correlate to basically word size. So 256 correlates to 32-bit words, and you may see a SHA-5112, and that correlates to 64-bit words. So as you go through the space, you can kind of think of this as one of those really fundamental building blocks of not just the Web3 space, but cryptography in general. So as that is kind of percolating in your mind, I do want to talk a little bit about keys. And I'm sure that we've also heard keys discussed widely in the space as well. And I think they're a really awesome tool because they basically serve as a form of identity management within the space. It gives us a synonymous way of validating transactions and tracking state changes. And there are kind of two ways to think of key derivation. You have asymmetric cryptography and symmetric cryptography. So with asymmetric cryptography, and this is the type of cryptography that most of us are used to, basically you're using a public and private key. With symmetric, you're using the same key to decrypt and encrypt, which you're not going to see with asymmetric keys. And you may have also heard that along with providing a digital signature to transactions, it also works as a way of encrypting data from plain text to ciphertext or secret text. So kind of a lot of scientific terms that I just threw at you, but broken down, these are kind of the pieces of the space that, one, you'll hear a lot about, whether you read a white paper or whether you're just casually learning about cryptography, whether that's learning about how public and private keys interact. So just a little bit more that you can kind of take with you. And to really wrap this up, cryptography, both the science and the movement, kind of moves in tandem with privacy policy. And it really informs how we want to move throughout the digital space. And I really like talking about cryptography, both the history and the science, because it gives a little bit of background on not just how we can use that in our own daily lives, but also I think it provides a little bit more accessibility to this very cool type of science that helps us create more secure and private systems. So I knew that was a lot of information that I just threw at everyone. So I'll let that percolate and I will transition over to Val.
Cool. I love the comment. We want to move through the digital space like ninjas. It's great. Thanks, Sandra, for always providing good quips. Cool. All right. So basically, I'm going to kind of build on top of what Gabrielle presented and talk about two things. So one, decentralization, which she mentioned earlier, and the second, blockchains, and kind of go a little bit deeper into the architecture of some of these tools and technologies. So let me start sharing my screen again. For those of you who have seen me speak before, you know that I like to use diagrams and draw everything out. And so that's what I'm going to be doing right now. This is kind of like an outline of some of the topics that I'll run through. So first, I'm going to just talk about Web2, and then basically, you know, how we, like what Web2 is and kind of how we have shifted our focus from Web2 to Web3. So I'm going to do that by creating some nice little diagrams here. So first, just thinking about Web2, I feel like when I first learned about Web3, I didn't really realize there was a Web2 or like a Web1. Like I didn't really have that in my understanding of how the internet works. So I think that it can be helpful to kind of just use that as a baseline. So the way that I like to think about Web2 is really about how data works and how data flows through the internet today. So I put these three nodes here, and they're pretty self-explanatory once I type them out, right? These are kind of the major organizations that make up the internet in a lot of ways. So Facebook has you know, billions of users. It has other properties like Instagram. So like all of kind of the social things that we do is mostly controlled by Facebook. Even applications that, you know, are like other applications that exist in the Web2 space usually have some interaction with Facebook, whether it's through advertising or like sign in with your Facebook account, sign in with Instagram. So Facebook is, you know, one of those kind of like social hubs where data just like flows mostly into it and not really out as much, but data flows into Facebook. And then of course, Google for like all of our services that we use. So, you know, Google Docs, Google Maps, etc., search. So they kind of control mostly the curation of the information that we're using, the curation of websites and apps that we discover, and also like more of the enterprise level kind of data that's being used. And then Amazon, for those who don't know of Amazon Web Services, so you probably just, when you think of Amazon, you think of like all the stuff that we purchase that gets delivered to us. So that's one aspect, right, of the control of physical goods and the information associated to that. But of course, Amazon also has like Whole Foods now. So the things that we eat, they know about, but also Amazon Web Services, which is kind of like one of the major pieces. So Amazon as an organization, they basically run servers that host pretty much all of the internet. I feel like it's 50% because I think one of their like services went down the other day. It was like half of the internet was like down because people could not connect to their websites. So, you know, most companies are using Amazon Web Services to some degree, whether it's hosting their website, hosting like their data, doing analytics, etc. Google, of course, also has their own like cloud service that people use as well. So basically the point is, right, most of our information is contained amongst these three. Of course, there's a few more, Microsoft, Netflix, etc. But these are, you know, just an example of some of the major players. And so in Web 2, what happens is our data kind of gets circulated between these entities. And I like to think of it as like a Bermuda Triangle, because, you know, things go in here to die. Sorry, that's over dramatic, but you get the point. So all of our information in Web 2 is stored here. And the kind of major like impetus for having this thing that is Web 3 is to avoid the issues that we find in here. So things don't literally go here to die, but basically what happens is once things end up in this triangle, we never really see them in terms of getting like full transparency into how information is being used and how it's like flowing between these properties, right? So they're private entities. We don't really know what happens behind the scenes. Even if you work for these companies, you don't really know what's happening behind the scenes at all times. So Web3 is about kind of breaking that up, right? And saying, well, the internet actually doesn't have to look like this, and we can avoid the issues of, you know, having all of our information be centralized in a black box. And so Web3 has a very different topology than this. And I'll just kind of diagram it out like this, where the size of the circle becomes a lot smaller. So each individual kind of actor in the Web3 ecosystem is not as large, right? They probably are smaller in terms of like headcount. So people that actually work there for the organization, if it is an organization. It could also just be like an individual person. And in addition, they're probably smaller in terms of you know, how much traffic goes through them and how much data they hold. So we have these smaller kind of nodes that are in the Web3 ecosystem, and these nodes are also connected to each other. Ooh, this is not a very pretty connector, but that's okay. We'll go with it. And so these nodes can be connected to each other. And this is what you can think of when we say node. This could be, again, like it could be an individual, it could be an organization, but generally you can think of it as some computer, right? So someone's computer is connected to this network, and we call them a node in the network. And so Web3 has a topology that is definitely more complex than the previous one, but it also means that there are more people involved in the process, and there's more flows of data. And in addition to that, there's more transparency in terms of what the data is and where it's going. So that's kind of like the major differentiator when it comes to Web3. But the question is like, okay, well, how do we actually make that possible? And so that's where I like to talk about Bitcoin as kind of the next evolution of this. There are many peer-to-peer networks that have existed for a while. BitTorrent is one that people probably have heard of as like a way to share files in between computers. And then Bitcoin is another kind of peer-to-peer network. So you probably know of it as a currency. It definitely is a currency. It's also a blockchain, but it also is one of these networks. And in the Bitcoin system, you have these nodes, right, that are peers, and they're sharing information with each other. And the information that they share is about transactions, right, for this ledger. So you have a similar topology as the one that I showed here. And the major kind of differentiator between, Bitcoin as a peer-to-peer network and BitTorrent, for example, is just the information that's being passed around. So Bitcoin kind of achieves this system of decentralization by allowing multiple people to participate in the protocol. And that means you now have this currency, right, that is decentralized and transparent. And so that's really like the amazing thing, I guess, the amazing innovation that Bitcoin brought us. And so with that, we want to understand, well, like, how do you achieve this, right? And how does this evolve? And so that's where we talk about like some of the cryptographic primitives that are involved in this. So the first thing is I'd like to kind of sketch out the topology of Bitcoin a little bit and other blockchains. So a blockchain, right, it's a chain of blocks. I know that sounds like obvious, but we can dive into what that really means. So each of these are blocks and they are linked together to make this blockchain. This is a data structure. And so for those who have a computer science background, that'll be familiar. For those who don't, a data structure is basically, also sounds really redundant, a way to structure your data, right? And there are many different ways that we can structure data. We can have a list of items, that could be a data structure. We can have something like this, which is like a linked list of items. You can have like tree structures, etc. So when you think of a blockchain, you should really just think of a data structure that has this sort of topology. And so in each of these blocks, we keep some information. And the information that we keep is what transactions are inside of the blockchain. So here we have some transactions in there. We have transactions in here as well. And so what we're doing is we're taking a list of transactions and we're linking them together by these blocks. And then the cryptographic primitives that we use to do that are first, for a transaction, we have signatures. So every single transaction is going to have signatures, so cryptographic signatures over them. And the signature basically says that the person who's making the transaction is authorized to do so, right? They have the keys, the cryptographic keys, that makes them eligible to actually perform this transaction. So we have crypto signatures as one part of our transaction. And then of course, in our transaction, we have the amount, right, that the person is sending. So, if I want to send 5 Bitcoin, I basically would generate a piece of data that says, here's the amount, it's 5 Bitcoin, here's my key, and then I will use my key to sign that transaction. And then when I publish that transaction to the network, the rest of the network has the ability to verify that I am actually the person who owns these Bitcoin. So that's another kind of important aspect of this is in our peer-to-peer network here, we are sharing information between each other. And in our blockchain, we are doing something similar. So these transactions that we create, we are publishing them or sharing them with the rest of the network. And that gives the network the ability to verify the information that we want to add to this blockchain. So I guess I didn't explicitly say this before, but the blockchain itself, right, is a data structure that is shared amongst all of the nodes. So every node in this network keeps a copy of the blockchain. And again, as I create transactions, I publish them. So each of these blocks has these transactions. And then the way that we kind of compose this structure is by taking a hash over each block. So as Gabrielle mentioned earlier, we have hashing functions that we can use to, again, verify the information that is being sent to us. So for example, if I have this list of transactions, and let's say I have 5 of them, and I send those 5 transactions to Gabrielle, I have signatures over all of them, so she can go through each of my transactions and verify that I signed them and I am who I say I am. So that's fine. But the next thing that she wants to be able to do is, send that data on to someone else so that they can actually do the same sort of verification process. And one way that she can do that is by generating a hash of all of those transactions. And when she generates that hash and sends that hash over to someone, that's kind of like a unique identifier for the data that she sent. So she not only sends the transactions, but she also sends the hash, right? So that person now can use the same hashing algorithm. They can run a hash with those transactions, and they should get the same exact identifier that she sent to them initially. So basically, out of this hashing function, you would have some output, which would be something like A1, B2, C3, right? Like that's the unique identifier for this data. And then if I have a list of transactions that is different, so let's say this is transaction list A, if I have transaction list B, then my hash would be something different. It would not be the same because the data underneath it is also different. So D4, E5, do I know the alphabet? Yes, okay. So that's basically how hashing functions work. So they're a way to verify that the information that you're receiving is what you expect to receive. And this is really critically important in any peer-to-peer network because you're receiving data from multiple people. You want to make sure that they haven't tampered with the data. And so hashing is our mechanism of doing that. So those are like kind of how some of those cryptographic primitives get used in a blockchain, but also these primitives get used in plenty of other everyday things that we do on the internet. So when I go to a website, right, I have HTTPS in the address bar, right, for the website that I visit. That is basically denoting that there is a certificate that was signed with a cryptographic key, a signed certificate to say, okay, this is actually the domain, or this is the information from the domain that you are trying to hit. So that's like one example of where cryptography is used. For those of you who use Telegram or Signal, the messaging apps, they're also using cryptography to encrypt your messages as they get sent. So, cryptography is being used in a lot of different places, but it really, really is like a core mechanism for these applications, especially ones that are trying to decentralize information. And so that's basically how it gets applied in a blockchain. Okay, so that covers that. Bitcoin, cryptocurrencies, IPFS. Okay, so the other things I wanted to mention briefly, this blockchain is an example, a very, very simplified example of what Bitcoin looks like and what Bitcoin is kind of how it's composed. But other cryptocurrencies are doing similar things. So Ethereum, for example, is also kind of structured in a similar way. The major difference with Ethereum is that the transactions are no longer just amounts of the currency that you want to send. With Ethereum, your transactions actually become programs. So an Ethereum transaction has some data that basically tells you, that you can run a certain program. And so that's kind of one of the key differentiators of the Ethereum blockchain. Other blockchains, most of them look similar to Bitcoin, but have like slightly different variations, I guess, that make them a little bit unique as well. Okay, so there's many different cryptocurrencies. They all have like the same kind of fundamentals, but with variations. And then the next thing, the kind of like next evolution of using a blockchain for transactions or using it for like programmable transactions is using a peer-to-peer network for data, right? So when we think about Web3, it's not just the cryptocurrencies. It's also like all of the other kind of decentralized technologies and products that we can use. So one of the more well-known ones is called IPFS. And I think it'll probably be helpful to copy this over as we talk about that. Okay, so IPFS, it has this really long name that is kind of weird. Interplanetary File System. Great. Okay. So around the same time that Ethereum was created, I think it was 2015, I want to say, around that time, there was a team called Protocol Labs that built a system called IPFS. And IPFS is it's also decentralized. It's also a peer-to-peer network, but it is specifically geared for sharing data. So similar to BitTorrent, how BitTorrent is used to share files between people, IPFS has kind of similar aims. So basically, any node that is in the IPFS network has this piece of information. It could be an image, it could be a set of files, could be a website, really anything. And they then share that data with other nodes. And they do this, again, in a verifiable way. So they're using cryptography, they're using hashes in order to get unique identifiers for each piece of data. So if I have an image, okay, so imagine this is an image. If I use the IPFS system, I would get a unique identifier for this image. So it could be something like that, right? And again, this is my way of ensuring that if you send me an image, and you send me that unique identifier, then I can verify that what you sent me is correct. And I can use the same kind of algorithm in order to ensure that this image is the one that it should be. So that's kind of like the basis of how IPFS works. And so one of the great things about a system like this is that no longer do we have to rely on like data being restricted to a large company that has their own servers, but now we can actually share that data between individuals through this peer-to-peer network. And so that means that the data that I create, I can hold on to, I can share it with other people, and I can receive data that way as well. So that's like one of the kind of next major evolutions, I guess, of the Web3 ecosystem is thinking beyond just cryptocurrencies towards more decentralized systems to handle our data. So that is one major piece. And I think there was one last thing, linked data. Yeah. Okay, so I have this data in my peer-to-peer network. And then another kind of like next step of that is being able to demonstrate relationships between that information. And so that's where linked data comes in. And so in this setting, you can think about not only do I have like, a Bitcoin network, an Ethereum network, an IPFS network, but now I can actually have multiple networks. I can have multiple networks that are operating simultaneously, but also have the ability to exchange information between the two of them. So you imagine that this is IPFS, and maybe below we have Ethereum. There we go. And these networks can actually interact with each other. So you might have nodes that are in here that are running both protocols. So like, let's say this red node is running IPFS, it's also running Ethereum, right? So now it has both of those pieces of information, and it has the ability to link that information together. So one way in which we are actually currently doing this is with NFTs. So NFTs, they live on a blockchain like Ethereum, but they actually point to information that's stored in IPFS. So when you go to the Ethereum blockchain, you look up the token ID for your NFT. That will resolve to a URL. You can look up that URL, and it will actually point to an image that's stored on IPFS. And so now we are like creating this link between these two networks. And then you can kind of use that as an example to extrapolate to see how data would be linked even further as the Web3 ecosystem grows. So different protocols will now have these points of interaction that allow them to speak to each other. And that's basically in the Web3 ecosystem, that's one of like the major pieces of work that we are trying to get towards, is creating standards that make these networks interoperable. So yeah, that's pretty much what I had for today, and where we can pause, and would be happy to take any questions. I'm sure that there were some things that I said that probably were confusing, or I might have misspoken. So feel free to jump in. This is the opportunity.
I had a quick question. So does IPFS work with any blockchain, or is it just Ethereum?
Yeah, so IPFS doesn't rely on a blockchain, but it can have points of interaction with other blockchains. So the NFT example is like NFTs actually, can include IPFS URLs in their metadata. And so that's like one point of interaction. But yeah, you can really use them with any blockchain as well. So if you have, if you have an NFT on Avalanche or Polygon or Near, those can all interact with IPFS. But really, it comes down to making sure that those interactions are standardized. So if I'm like consuming that data as an app developer, right, I know what to expect and I know how to use it. And so when we come up with standards for these interaction points across different protocols, then that's when we can really like build apps. Right now, it's like pretty crude. It's just like, okay, you put a link in your NFT metadata and that's it. But there's no like community-wide like agreed upon standard for how that should work. I mean, there is like, there's in the Ethereum community, there's like the ERC 721 metadata spec. But as the community matures, we'll have like more sophisticated ways to map this data. And then, you can imagine like the different apps that can be built on top. But yeah, so it's not limited to Ethereum per se. That's just like what everyone's using right now. So it's like the most common.
Thank you.
Yeah.
Cool.
Was there anything that like piqued anyone's interest? Like, are there any areas of this that you're like, oh, I want to learn more about this?
Yes, I want to learn more about programming these hashing signing things. I think I've done my second project of the signing stuff and it's still overwhelming in terms of implementation.
Yeah, so Sandra and I were looking earlier today at how to verify signatures in a Solidity smart contract. And yeah, this is a good example actually, because basically like there are different kind of Web3 like libraries that developers can use, but they have different ways that they do the same thing. So there's a library called Ethers, and there's one called like Web3.js. And they have different ways of signing. And so then when you go to your smart contract and try to use that signature, like it's hard to figure out how to do it because the methods are different. So that's just like one example of how, this is still a very young ecosystem. We still have a long way to go. I guess like another way to ask this question would be, if we did another event in the future, like what would you want it to be about? We'd be really happy to like try to bring in people who have expertise in areas where we don't. So if there's anything, just feel free to let us know.
Decentralization and the 51% attack. For instance, as Bitcoin gets harder to mine, miners have to combine hash power. So what if it gets so hard to mine that there is one super combined hash power? How does that affect the decentralization bit of it?
Okay, that's an interesting question. So so you're saying as it gets harder to mine, so Bitcoin does have a way to regulate the difficulty of mining. We didn't really talk about how that part works this time, but basically like every time you want to add data to the blockchain, you do this thing called mining, which is essentially hashing. Generating a hash that has certain properties. And so, but within Bitcoin itself, there is like a regulation, which is like they restrict the time that it takes to generate a block to like 10 minutes. And so by keeping that relatively around 10 minutes, by keeping that restriction, that means like if mining gets too difficult, they change parameters so that you can still fit within that 10-minute window. But the other part of your question was like, what happens if all the hash power combines and then it's like it's too centralized basically.
Yeah, because it seems like at this point, it's hard enough that one person alone, probably it will take them a decade to mine something. So people are combining their hash power. Mm-hmm. And what if it gets too combined?
Yeah, that's a really good question. I feel like there's a lot to explore there because it really depends on like how much you care a little bit. Like there's already like mining pools. So people basically pool together their compute, right? Their like computation power. And the idea is that if enough people are in the network it's competitive enough because everyone wants to like earn money that you shouldn't have these points of centralization. Though the mining pools themselves are kind of points of centralization, I feel like there's a lot in there. I don't know, Gabrielle, if you have.
No, there's definitely a lot in there. I think also just I think it's also a philosophical question too. Like,
Yeah.
when would that point be? Because you have to have enough people who are willing to mine and will or have that much power in addition to willing to mine it. And because there's so many different ways that you can mine now, like cloud mining and like you said, mining pools, and you don't have to do this necessarily on your own. When would that point be? But also there have been a lot of discussions within the space about, okay, will there be a point when it's no longer decentralized and we have those those pockets of centralized-ish power, and how do we make it more distributed? So I feel like I've heard that conversation a lot.
I don't know. It's kind of like a little bit scary because it's like, like the reason that this worked, I think, was one, because the founder was unknown. So it was like, no one cared at the beginning. And also like, because no one cared, it was just like easy for it to spread. Right. And then as like, traction went on the price of the token, then, more and more people were like, oh, I should jump into this. But then it's like you get to a certain point where it's so lucrative that of course you have centralization, because like it's this rich get richer phenomenon. And so with Bitcoin, it's like, who really knows what's going to happen, especially because they're now, approaching like they're approaching like the supply basically being fully circulated, right? Or fully mined. But with other protocols like Ethereum or like other, proof of stake protocols or proof of not work protocols, they're trying to avoid the same thing from happening, the rich get richer phenomenon. So if you can avoid that, it still could become, worth it for new entrants to come in to the ecosystem, which could potentially decentralize your blockchain even more. But like, we haven't seen that happen yet. I don't think enough time has passed for us to really know.
Sounds like it's a very good idea for all. I'm not talking about the moon coins, but all these reliable cryptos that are coming out to balance out, a potential situation of the dollar. Everything is pegged to the dollar, where the dollar is the main currency. And it's nice to see that it's not just Bitcoin or Ethereum or the top 10. It's nice to see that there is thousands, I think, trying to make it with different functions. So there is hope.
Yeah, we'll see. It's exciting. I don't know. But it's like an opportunity to shape it, so that's a cool thing too. I think from my perspective, since I work for a startup, it's kind of like you don't really know, like you kind of are just guessing. So like the bet that my team is making is that applications like need an easier way to basically enter a market, right? They need an easier way to actually get users and like try to prove that their application is valuable. Right now, that's really hard to do because like if you create something that's moderately competitive with Facebook, they basically control how large you can get, or they acquire you over time. And so our bet is that like if you have shared data, right, that anyone can interoperate with and that is controlled by users instead of companies, that it'll make it better for businesses and it'll make it better for users. But we're really not sure like how that's going to pan out. So yeah, it's finding the thing that's valuable is really, really tough. It's just a lot of experimentation in my perspective.
Yeah, it's the same. Like my company, we're working like with music and artists and like trying to find out like how to bring back the power from like the major labels and like bring the power to fans and like actually like creating things that actually that is good for the artists, not like throwing away or like middle stuff or like royalties and handling this kind of stuff. But it's still feels like there is, as soon as we actually come up with something cool, like Spotify are just gonna buy it or gonna steal the idea. So like you want to like do stuff that actually are helping the world or like the artists instead of like, yeah. So it's very interesting, like in this kind of area, like how to bring this technology to actually help and give power back to those who actually are the artists or the creators.
Yeah, it's a really interesting intersection, because I feel like there are quite a few projects that, like, I feel like people know that like there's something about Web3 and creators, like what really is that clicking point? But yeah, I don't know, that kind of makes it fun too. But yeah, feel free to connect with both of us. So Gabrielle on LinkedIn. All right, well, we will sign off, and yeah, we will have more events soon. So yeah, we'll let everyone know about it. But thanks again, Claire, also, and just like Web3 Baddies for making this possible.
Bye, everyone.
Bye.
Bye.
Bye.